Good morning or maybe afternoon, grade 11. We'll be starting a new chapter after the factoring chapter on Introduction to Quadratic Functions. This lesson, I'll talk about what is quadratic functions, and I'll also talk about our topic, which is connecting zeros, roots, and x-intercepts. Now, before I talk about the zeros, roots, and intercepts, I want to first talk about what is a quadratic function. What is a quadratic function? And first of all, I want to highlight what is the meaning of function. Now, you should have learned last year in grade 10 that a function is written as f of x equals to some x value, for example, 2x plus 3. And each x connects to this x. You may have seen the diagram where you have a function where you have values of x, where is x1, x2, x3, x4, x5, and so on. And each one of these x connects to one value of y. We can have two values of x that connect to one value of y. That also works, y1, y2, y3, y4. And that's fine as long as each 1x is connected to each 1x has a corresponding y value. If we have one value of x that connects to two values of y, like that in green over here, that is not a function. It has to be one value of x that corresponds to a value of y. Oops, sorry about that. And so this is the meaning of function. Now let's bring up a very simple function that f of x equals 2x plus 3. You may have seen before equation written as y equals to 2x plus 3, in which the y value will be whatever x value you put in, y would correspond to that. So for example, if I substitute x equals to 2, then we have y equals to 2 times 2 plus 3, in which this now becomes y equals to 5. Okay, but in function notation, we write f of x is equal to 2x plus 3. And then we can, instead of writing this, substitute x equals to 2. Instead of writing this now becomes f of 2 equals to 2 bracket 2 plus 3. And then that becomes 5. Oh, sorry, not 5. Sorry, that's not 5. That's 4 plus 3, which is 7. Okay, so that is the meaning of function. So hopefully we kind of reviewed the meaning of function. Now, next I want to talk about what is a quadratic. Forget about these for now. We're going to look at those later. Let me move them down first. So, what is a quadratic function? Now, in a quadratic function, the word quadratic means that our x must be in degree of 2, which means that our formula f of x, our highest exponent of x, must be a square. So must be square. Now, our quadratic functions can come in different forms. So our general quadratic function will be f of x is equal to ax squared plus b of x plus c. And so this is our highest degree of 2. That is a quadratic function. Now, each of these a, b, and c, these are called our coefficients. They are just numbers. It can be any numbers. It could be a decimal, it could be a whole number, it could be a fraction, it doesn't matter. And then our x is our function. So our whatever we put in here, we would substitute in both of these x's. Okay, so that is what we call a quadratic function. Now, there is another form of the quadratic function. First of all, this is called standard form. And there is another form called the vertex form, in which f of x is written as a of x minus p plus q. And this is, this is a square. And then once you multiply out the bracket, it actually goes into standard form. But this is called the vertex form. We will look more into vertex form in future lessons. So let's go back to a quadratic function. I want to look at an example. And this will be the most simplest quadratic form, quadratic function. Simplest quadratic function, that is f of x is equal to x squared. I don't have any coefficients. My coefficient is 1, and I don't have any other intercepts. I don't have bx, I don't have c. We're only looking at f of x is equal to x squared. Now I'm going to bring this back, and I'm going to move these away. We're going to look at these later. So, what I'm going to do right now is we're going to plot what this function looks like. So, to start with, we're going to do a table of values, x and f of x. And this is for f of x is equal to x squared. And so let's start with -3, and then we'll do -2, -1. We have 0, 1, 2, and 3. If I plug in -3 into our function, this will be -3 whole squared, which is equal to 9. So I'm going to put in 9 here. This will be -2 whole squared, which will be 4. And then this will be -1 whole squared, which will be just 1. And then 0 squared is 0. And then we have 1 squared, which is 1. And then we have 2 squared, which is 4. And then we have 3 squared, which is also 9. Now, if we're going to plot this in our xy coordinate plane, let me quickly roughly sketch out a coordinate plane. We have y, we have x, we have 0 in the middle, and this is 1, 2, 3, -1, -2, -3, and then we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 coming up here. Let's start with -3. -3 will be plotted at 9 right here. -2 is 4 over here. -1 is 1 over here. 0 is 0 here. 1 will be 1. 2 will be 4. 3 will be 9 again. We have this sort of shape. And if I connect the dots, this is what our function kind of looks like. Okay? And this shape here, this U shape, is actually called a parabola. Parabola. Okay? This is what we call parabola. And all quadratic functions are parabolas. It doesn't matter what kind of a I put in, and b I put in, and c I put in for the ax squared plus bx plus c, they will all look like parabolas. Sometimes they look like a U, sometimes they look like an upside down U, but they still generally look kind of similar. Now, Going back to our main topic, which is connecting zeros, roots, and x-intercepts, let's look at our our f of x. Well, let me label this. F of x is equal to x squared over here. This is our function. This is our graph. And then when we look at the meaning of 0, it actually means when we put y, 0 means when y is equal to 0. So I'm going to kind of trace down over here, trace down to y equals to 0 right here. This is our y equals to 0. Then we would see that our x, when y equals to 0, x is also equal to 0. And this is what we call our root. There is only one. It touches the 0 right there. So if I zoom right in over here, I know my drawing is not the best, but this actually touches at this point. It touches over there. And that's what we call the root. It is also what we call the x-intercept, because this is where the graph intercepts the x-axis. So the xy coordinate, if our function is plotting like this, then this right there will be intercepting the x-axis. That's why it's called the x-intercept. So in other words, zeros, roots, and x-intercepts are all the same. Now, remember from the last chapter, the last couple of lessons, we talked about finding the roots, finding solving the equation. Those are pretty much the same. We are finding the x-intercepts. We are finding when y equals to 0. That is why when we factorize our equation, we set that equation equals to 0. Okay, so let's look at some actual examples. Now we're going to go into some example 2, for example. Okay, so let's look at this one next. We're going to look at this function right here. I've already put it down and I've kind of graphed it out for you. Now, this is a function where f of x, this is our function where f of x is equal to x squared minus, oh, I left out a 6x. So let me rewrite that. That is x squared minus 6x minus 6. Whoa. Oh no, it is correct. 6x squared minus, oh, it should be x. Yeah. This is x squared minus x minus 6. Okay, this is our function, and this is what it looks like. And so when the question asks us to find the x-intercepts, well, so if I trace down my graph like this, I'm going down, I'm going down, I'm going down. The moment it passes through this x-axis, this is called the x-intercept. X-intercept. Now notice if we continue up here, it actually has another one. So that's why there's x-intercepts. Okay, so as we move along, we will pass through this x-axis, and then we will have these x-intercepts. And so how do we find them? Of course, in this graph, you can see that it passes through -2 and 3. But we can actually solve it by factoring. So if we look at this, f of x is equal to x squared minus x minus 6, we can set this equation as equal to 0. So we would do x squared minus x minus 6 equals to 0, and we would solve it normally. We have 3 and 2, -3 and 2, and then this will be x minus 3, and then x plus 2 equals to 0. And then we would say that x is equal to 3 or negative 2. That is here and here. Okay, so that is finding the x-intercepts. That is also called finding the roots or finding the zeros. Okay, so they are all the same. It's different wording, but they all mean the same thing. Let's look at another one over here. Let me drag this back up. Oops. Now, this time, you would see that our equation, let me write it better. F of x is equal to negative x squared minus 3x plus 10. This is what our function looks like. Okay, and then again we have to find the x-intercepts, or let me use a different wording. Find the roots of the function. And so how do we find the roots of the function? We will set our y value to equal to 0. That is the same as the zeros. That is also same as the x-intercepts. And so we would write down negative x squared minus 3x plus 10 is equal to 0. And then we would do the same factoring as before. This one will be negative 1 and 1. And then how do we get 10? How do we get 5 and 2? Does that work? Minus 2 plus 5. Nope, it is the other way around. It is going to be 2 and 5. Negative 5 plus 2 will give us negative 3. And so we can write this as minus x plus 2. And then this will be x plus 5 equals to 0. And then once we solve our equations, we have negative x plus 2 equals to 0 on one side, and then x plus 5 equals to 0. Then we will have x equals to 2 and x equals to negative 5. And so our roots, x is equal to negative 2 or 5. And so our roots are negative 2 and 5. And oh, sorry, this is 2. I wrote it wrong. I swapped it around. I was wondering why it looked kind of weird. I even wrote it x equals 2 and negative 5 here, but I wrote it wrong. 2 or negative 5. There you go. So the roots are 2 and negative 5. And does that coincide over here? That's 2, and that is also negative 5. So this is basically our introduction to quadratic functions. In the future lessons, we will be looking more at the standard form, looking more at the vertex form, and looking at some interesting properties of the quadratic function, such as this value up here. This will be called the maximum point, maximum, or we also call it the turning point. And it is also called the vertex. And then we also have this one, in which this point is called the minimum, or it's called also called the turning point or the vertex. Okay, and there are other properties such as this line of symmetry and also this line of symmetry. We call these symmetry lines. Okay, same as this one. Okay, so we will look at that in the next few lessons and how we can quickly sketch out these parabolas just from looking at the vertex form. Okay, now I will also post a set of questions for you to practice on. I don't have the textbook with me right now. I may get it sometime in the future. I go to school and get it so that I can probably take some pictures of it and then do some class examples from there. But for now, I will look for some questions, or I will make some questions, and then I will post it on PowerSchool. Please download that and also do the questions, take a picture of your answers, and then post it in the discussion forum. I will create a discussion forum. Please do it, and I can check who has done it or not. Okay, if you have any questions, please email me, or you can also post it at the discussion forum what your question is and what you don't understand. That's it for today, and I'll see you all in the next lesson.